Uh, Good afternoon, students. Welcome back. Welcome to the first recorded class of operating system. I just thought of recording a video to you people so that we can compare this mode of learning with already what we have been doing since 1 month. That is, we are learning through YouTube already. Recorded. Someone the video is recorded by someone else. So let us see this option. If it works well, then we can continue with this, or we can go back to the previous mode of learning also. Or if you wish, we can use a Zoom app. That is also fine with me. So let us see and explore different ways. Okay. So let us begin with a virtual memory. Let us begin from the starting itself, because it is not very comfortable for me to begin somewhere in the middle of the chapter. So let us begin from the beginning. So this is virtual memory. So we are going to learn about these topics. Okay, so these are the objectives: to describe the benefits of virtual memory system, to explain the concept of demand paging, page replacement algorithms, and allocation of page frames, to discuss the principles of working set model, to examine the relationship between shared memory and memory mapped files, to explore how kernel memory is managed. So we will begin with the background. Code needs to be in memory to execute, but entire program rarely used. Okay, so we have to remember, since from the beginning of this course I have been telling you, code needs to be in memory to execute. So if the code is not available in the memory, it cannot be executed. So when I say memory, it is a main memory, that is RAM. Okay. However, if you see whatever is required, okay, for example, if you have around 4 GB of application, all the 4 GB of application should not be available in the RAM at one point of time. Okay, so out of 4 GB of the application, only 100 and 200 or 200 or 300 MB may be in use right now. So only you keep only those 200 or 300 MB of information in the RAM, and rest all other, around 3 and 3.5 GB of let the application be in the hard disk itself. Okay, entire program code needed at same time, code not needed at the same time. Consider ability to execute partially loaded program no longer constrained by limits of physical memory. Okay, that is the advantage of virtual memory. So the meaning of virtual itself is which is not real. Okay, so when we buy a laptop, maybe we use 4 GB laptops or 8 GB laptops, but the amount of program, so many programs we have installed, so much of information we have stored in our laptops. Okay, our Windows itself takes around 7 GB to 8 GB, and we are able to run it in a machine of just 4 GB. It is all because of virtual memory. Okay, it is all because of virtual memory. So that is the biggest advantage of virtual memory. Each program takes less memory while running. More programs run at the same time. Okay, so with the advent of virtual memory, you can have more programs at any one point of time in the main memory. So increased CPU utilization and throughput with no increase in response time or turnaround time. Okay, so because of this, you can better make use of the CPU, because if less programs are there in the memory, means CPU has to wait, or CPU has to be idle most of the time. Okay, less input output needed to load or swap programs into memory. So because of this, each user program runs faster. Okay, less input output needed to load or swap programs into memory. So this is a background. Virtual memory, it's a separation of user logical memory from the physical memory. So we have to understand, it is a separation of user logical memory from the physical memory. I think in the last chapter you have already studied the difference between what is that, logical memory and physical memory, right? I think it is here. So let us go. It is here. So what is the difference between logical memory and physical memory? The concept of a logical address space that is bound to a separate physical address space is central to proper memory management. So logical address basically generated by the CPU, also referred to as virtual address. Okay, so logical address also called as a virtual address. Then physical address, address seen by the memory unit. Okay, remember all the processes only see the logical address. Okay, processes cannot see the physical address. Logical address and physical addresses are the same in compile time and load time. Okay, however they differ, they get changed during execution time and address binding scheme. Why this is because, okay, during compile time and load time still the process is not bought into the memory. Okay, only during the execution time and binding time the process program will be brought into the main memory. So what is a logical address space? Logical address space is a set of all logical addresses generated by the program, whereas physical address space is a set of all physical addresses generated by a program. Okay, I hope it is clear. I think we will go back to that this one. Yeah, virtual memory, it's a separation of user logical memory from the physical memory. Another important point you have to remember is physical memory is always lesser than logical memory or virtual memory. Okay, there is no limit to the virtual memory. Okay, only part of the program that needs to be in memory for execution. Logical address space can therefore be much larger than the physical address space. Okay, allows address spaces to be shared by several processes, allows for more efficient process creation, more programs running concurrently, less input output needed to load or swap processes. Okay, hope it is clear. These are the advantages of virtual memory. Because of virtual memory, you can have many processes simultaneously in the main memory. Because of this, CPU utilization as well as throughput will be better. Okay, since more memory is available, more process can be created. So more process creation, then more programs will be running concurrently. Okay, so less input output needed. Okay, to load or swap processes. Then virtual address space, logical view of how process is stored in memory. Okay, try to understand logical view. It is not a physical view. Physical in the sense which is tangible, which you can touch. For example, 4 GB RAM is a physical memory. Okay, 4 GB RAM is a physical memory. Logical view of how process is stored in memory usually start at address 0. And contiguous addresses until end of the space. Okay, virtual address space always start, okay, at address 0, and it is contiguous addresses until end of space. Meanwhile, physical memory organized in page frames. Okay, the MMU must map logical to physical. So what is this MMU? It is a memory management unit. It is basically a hardware which converts your logical address into physical address. Okay, I hope you have understood the difference between a page and a process. So if you have not understood, we will understand it now. I'll take just 5 minutes to understand what is the difference between a page and a frame. So how you can implement a virtual memory? You can implement virtual memory with only using these two techniques. The first one is demand paging or demand segmentation. So you have to remember this. Virtual memory can be implemented via, the first one is demand paging and second one is demand segmentation. So we will continue with the next next slides in the next video. Otherwise size of the videos will be very larger. Okay, so thank you for listening. Hope it works well.